Lesson 4.6, prove triangles congruent by angle side angle and angle angle side. First of all, we have a new postulate, postulate 21. It's the angle side angle congruence postulate. If two angles in the included side of one triangle, the included side, that means the side in between the two angles. So if two angles in the included side of one triangle are congruent to two angles in the included side of the second triangle, then the two triangles are congruent. So we have, if angle A is congruent to angle D, side AC is congruent to DF, that's the included side, it's in between the two angles, and angle C is congruent to angle F, then triangle ABC is congruent to triangle DEF. Also a new theorem, Theorem 4.6, angle-angle side congruence theorem. If two angles in a non-included side of one triangle are congruent to two angles in the corresponding non-included side, that means it has to be the same spot. It can't be two angles in this side and two angles in that side. It has to be the corresponding non-included side. Then the two triangles are congruent. So we have A congruent to D, C congruent to F, and then the corresponding non-included side congruent. Therefore, the triangles are congruent. Okay, can the triangles be proven congruent with the information given in the diagram? If so, state the postulate or theorem you would use. Here I have two intersecting lines and marked where two angles are congruent and two sides are congruent. You can also say that these angles are congruent because they're vertical. So I have angle, angle, non-included side, angle, angle, corresponding non-included side. So I have angle, angle, side. Yes. Let's do the next one. Here I have all of the angles are congruent, but no sides are marked. Therefore, no, you cannot. There are no postulates or theorems that can prove those triangles are congruent. There is no angle, angle, angle congruence theorem. Next, I see two angles, and then we can also say that that's congruent by the reflexive property of congruence. So I have angle, side, angle, and angle, side, angle. So yes, by angle, side, angle, congruence postulate. Flow proofs. Just put this slide in here to tell everybody we're not doing flow proofs. Flow proofs use arrows to show the flow of a logical argument. We're just sticking with two-column proofs. Okay, that's all we're going to work on in this class. Example 2. Prove the angle-angle side congruence theorem. So we're going to write a proof. We have lots of stuff given, and we need to prove that the two triangles are congruent. So let's work on that. I have statements and reasons. Okay, first we write down all the given. Angle A is congruent to D, angle C is congruent to F, and segment BC is congruent to segment EF because they are given. We can also say that angle B is congruent to angle E. We'll mark that in there. And we know that because of the third angles theorem. Okay, and if you remember, we can prove theorems using postulates, and we learned a postulate today. Sorry, this should be a 2. I always do that. We learned a postulate today that is the angle side angle congruence postulate. And now I have angle side angle, angle side angle. So we can say that triangle BCA is congruent to triangle EFD. Yes, I know I wrote that in a different order than how it's given, but if you look, BCA, EFD, their corresponding parts are congruent, so I'm good. And we just proved a theorem. Alright, you try. In the diagram at the right, what postulate or theorem can you use to prove that triangle RST is congruent to triangle VUT? Explain. I'm going to push pause. Okay, you know that angle RTS is congruent to angle VTU because of the vertical angle congruence theorem. Therefore, the triangles are congruent because of angle, side. Alright, crazy example. The Forestry Service uses fire tower lookouts to watch for forest fires. When the lookouts spot a fire, they measure the angle of their view and radio a dispatcher. The dispatcher then uses the angles to locate the fire. How many lookouts are needed to locate a fire? I've been in these fire towers down in Virginia, North Carolina. I mean, if you have a tree line, red trees, awesome. You know, out in the forest, there's a huge tower that you can climb up and walk around so you can look out over the trees. And if you see smoke coming up, like black smoke, you can see that there's a forest fire, and that's pretty serious down there. So let's read how to do this one. Turn in the page. My answer is B. The location of Tower A and Tower B and the fire form a triangle. The dispatcher knows the distance from Tower A to Tower B, so we know this distance, and the measure of angle A and angle B, so we know those three things. So the measures of the two angles and an included side of the triangle are known. By the angle-side-angle congruence postulate, all triangles with these measures are congruent. So the triangle formed is unique, and the fire location is given by the third vertex. Right there. 2 lookouts are needed to locate the fire. So if I go back, yes, crazy example, which is why we did it together. Okay, you try. We're actually not going to do this one. Next, another you try. Now we're back to the fire example. Example 4 was the fire towers. Suppose a fire occurs directly between Tower B and Tower C. If you remember, I had Tower A was here, and then B, and then a fire. We should make that red. And then I had C way over here. It says, suppose a fire occurs directly between Tower B and Tower C. Could towers B and C be used to locate the fire? Explain. No, it can't. A triangle is formed by the location of the fire and the tower, so the fire could be anywhere between B and C. I can't make a triangle between these, so no triangle. Okay, daily homework quiz. I have 3 questions. Here's 1, 2, 3. Write a proof. 2 points for this one, so 3 points altogether for this daily homework quiz. Go ahead and try them. Good job.